Bonjour, hyvää iltapäivää, good afternoon, ladies and gentlemen. So, I'm Hannu Toivonen. I will start the talk today. I will give the first half and then my current colleague, visitor, long-time friend Antoine will continue and give the second half of the talk. We are talking about artificial intelligence and using AI for languages, and boldly we are talking about all languages. Well, that remains to be seen, but maybe a bit more than just English. Here's an example from this morning. Using ChatGPT, I asked it to translate "kääriä vei potin" to French. And as we all know, language models such as ChatGPT are very flexible. They can generate text, they can work on many different kinds of tasks. They are versatile, flexible, they are even multilingual, as we can see from this example. They are not perfect, that's the problem. So it's not really the right translation here that we get, but anyway, it's a good attempt. And then, of course, as you can see from the topic, I sort of tricked the system with a difficult question that is ambiguous and involves information about Kääriä, the artist, the Finnish artist who competed in Eurovision Song Contest. But AI is, of course, much more than ChatGPT, even though this is extremely interesting, extremely popular, allows us to do things that we couldn't do before. AI is much, much more. So, as a quick overview of what the field of AI is, let me first start by saying that AI, artificial intelligence, the word intelligence in this term is actually a metaphor. When we talk about computational systems, computer programs, they are not intelligent in the same way as humans are. But since we lack better words, we use artificial intelligence as a metaphor for the kind of cognitive skills that computers might have. Also, many other terms that we use, like in the context of natural language understanding, for instance. The systems don't understand language the same way we do, so take it as a metaphor. AI obviously is a marketing term. We see lots of products being sold as AI regardless of what they do, because that is currently selling well. More concretely, what AI is actually thousands, if not millions, of different systems. So concretely, there's no single AI, but there are lots and lots of different systems, computer programs that behave in different ways that might be called more or less intelligent. And then, of course, coming from a scientific background, for me, AI is primarily a research area, covering lots and lots of topics. I'm not going through a lot of them because there are so many of those, but let me try to give you a bit of an understanding of what we talk when we talk about AI. So if this sphere, half sphere here represents the whole area of AI, one topic within AI is machine learning, but there are many, many other topics, from knowledge representation and reasoning, planning, robotics, machine vision, and so on. Within machine learning, there is neural networks, but then again, there are many other techniques of machine learning. Within neural networks, one particular popular technique is deep learning, but there are others. Deep learning is used to build language models, such as ChatGPT, but can be used for many other things as well. And then examples of language models are ChatGPT. So, in the division of work that we have with Antoine, I will talk more on AI in more general. I will talk about ChatGPT, but please keep this in mind, it's only the tip of the iceberg. And as we go further towards the end of my part and then Antoine's part, we will actually be talking about many of the other things in AI, what we've done in the past in collaboration. If you were to ask me for a definition of AI, this would be my favorite one. There are lots and lots of them, but this is my favorite one. Artificial intelligence is computer programs behaving rationally. I really like getting rid of the word intelligent because it creates false images in people's minds about human-like behavior. What it really boils down to is computer programs that act in a sensible manner based on the information they have, the resources they have to do computation, and so on. It can be something that is way beyond what humans can do, think of a simple calculator, or it can be something that is very simple and easy for us, think of vision, seeing what's around us. In the past, we have collaborated with Antoine in 2 projects. I just mentioned them here briefly. NewsEye, which was coordinated by Antoine, and Embedia. And these are examples of European projects where we did something different from ChatGPT. We were working on multiple European languages, also smaller ones like Finnish or Estonian, and using a multitude of AI methods. But now with this disclaimer, let me jump back to generative AI and language models. I hope you can see the image here, but I'm afraid you can't. This is a great metaphor of AI and of generative AI. This image has been produced with a computer program called Midjourney, and it has a woman here painting a picture of a very detailed android. It's very impressive to be an image produced by a computer. This is already from last spring, I think, and things have moved on since. Now, if you were able to properly see their image, you would actually, maybe after the first glance, realize there's something badly wrong. And what it is, oops, sorry, wrong button. What it is the hand here. It looks very nice, it's natural. It's her right hand, but it's actually connected to her left arm. And this is kind of typical for these generative systems, including ChatGPT. They can produce really impressive things, looking good, making a lot of sense at the first sight, but there's the risk that something is actually wrong. There are many other smaller things like she's looking at somewhere else, not where she's painting, and the painting and the background get blended here and many other things. So, a good metaphor of where we are. Our systems can do impressive things, but they can also do kind of stupid mistakes. So let me try to shed a bit of light on what's going on here. Let's get back to language models. So what language models do is to generate language, generate text. They take whatever text is given to them, and they then try to guess a good word to add to the text. So here's a simple animation of the system trying out different options and then adding a word after another one. So once it has added one word, it can then go on predicting the next one, and then the next one, and next one. It kind of improvises text. It doesn't plan ahead, but the positive interpretation is that it has all the possible plans in its metaphorical mind at the same time. So whatever it ends up doing, then it will continue from that. What's really interesting in these modern language models is that they are flexible. They can be used for many different kinds of tasks that can be framed using text, like asking a question, and the system will produce an answer, which might be correct or not. Or many other tasks, language translation, change of style, producing programming code even, and so on. These systems like ChatGPT have been trained on massive amounts of data. So they are based on machine learning, and machine learning is imitation. So what it tries to do is to imitate the training material it has seen in the training phase. And it's seen billions of words, if not trillions, so it's a massive amount. And what machine learning and language models do, they produce generalizations from the training material. They try to discover patterns and regularities. And then when they generate new text or a new image, they apply those regularities they have discovered to produce something new that obeys these regularities. And surprisingly good results can be achieved with this. So here's again the example that I showed you before. ChatGPT is not just the language model, it has that as a basis, but then it's been built and tuned in ways to act as somebody who discusses via chat. So to reply to the user, to follow instructions, to be safe and avoid topics that might be not suitable or even not legal. And then there are lots of extensions to language models, like this week OpenAI announced again new features, more fluent integration with images and so on, but we'll skip that. So I then continued the discussion, the chat that I just showed. It was not really correct. The ChatGPT didn't recognize kääriä, the artist, so I was asking for other possible meanings and translations. And it makes another good attempt, but doesn't really get it right. There are problems that I mentioned already. The text that I used I knew it was difficult for ChatGPT because of just the name kääriä. Another problem is, not really visible here, but let me just mention, is the Finnish language. Since it's agglutinative, words are inflected, there are endless forms of words that you can produce. It's very difficult to learn automatically. And then, of course, there's less training data in Finnish from which to learn these words and sentences and so on. But there are some more fundamental problems. Language models, they work on words, not on information or facts or knowledge. They work on words only. So metaphorically, we could think of a language model as playing around with fridge magnets, moving words around in order to arrive in an arrangement that looks like regular text in its training data. The point here really is that language models don't have access to any meaning of these words. They just manipulate strings, letters, characters, but not the meanings. We as humans, we see the meanings even behind of every single word here, not to mention the whole text. Speak. We know what these mean. We all speak. We've heard speech and so on. Language models don't have any access to any information outside the training data. Well, now, with extensions to databases and so on, web search, they do have some access, but the basic language model doesn't understand anything. So actually, this metaphor might be misleading here because we see meaning in the words immediately. For a language model, it looks more like this. Just some random identifiers it's shuffling around. And it's so impressive and surprising how well they do in so many tasks, despite being based on just manipulating words based on what they have learned and generalized from their training data. The lesson here is that the limitations of language models are exactly here. They can't do things where actually a meaning of those words or expressions is needed. They appear to do reasoning, like they can perform well in the Finnish matriculation examination, for instance, and many international tests. But it appears that that's based largely on having access to similar tasks from which they can sort of copy the ways of solving those. So they don't really derive new solutions, but they copy the old mechanisms that they already know of. So that's their strength. They have access to a massive amount of information, but the weakness is the information is in textual form. That's why we see also stupid mistakes made by these language models. So, talking of black box or invisible things, OpenAI, the company behind ChatGPT, is a private company, and we don't know how they have trained their systems, how they've tested them, so they are a bit of black boxes. We don't know what kind of biases they have, for instance, except by experimentation. But talking of these shortcomings, and the title that we had, AI for all languages, here's first of all a map. I have two maps. The first map is on the availability of OpenAI services. So we in Finland, France, Western countries, South America are in a happy position to have access to these tools. But many other parts of the world do not. Well, luckily there are also open source language models being developed. They are not as good yet as OpenAI's, so there will be alternatives. But just to highlight the fact that ChatGPT really is not all languages. It works maybe for 100, 200 of the languages of the world, while there are 7,000 plus minus 1,000 languages in the world. So most languages don't have any support from these major language models. And that's why we need different tools besides these. Here's another map of the world, distorted to represent the amount of material that goes into machine learning. This is not just language models, this is in more general for machine learning. We can see most of the training material coming from the North America, a good amount from Europe, not too much from Asia, South America small, and look at Africa, it's not represented at all. So if we take this roughly as describing what ChatGPT knows of, it knows of the Western culture, Western languages, and represents those. As a Finn, I'd love to have a model that knows something about the Finnish culture, not just the language, but also the culture, and can tell about that and doesn't enforce views that maybe don't fully align with the Finnish one. So again, motivation for needing other tools besides commercial large language models like ChatGPT. And I'll wrap up this with this slide, just quickly introducing something that Antoine will tell more about in a minute. Something we did in the NewsEye project was to develop tools to analyze historical newspapers from France, Finland, and Austria in the respective languages. And this project involved a number of steps where we actually needed tools things that couldn't be done with these large language models. They might be helpful in some specific subtasks, but they couldn't solve the problems here. Recognizing text in old scanned newspapers, where the quality of the newspaper, the print is not necessarily very good, so you have lots of errors in the text recognition. Then trying to search that information for some specific facts, but your text is noisy, has lots of errors because of the text recognition process here. You want to discover topics and trends, something a language model doesn't do by nature. And what we did in my group, we focused also on sort of competing act to ChatGPT generation of text to describe the findings done in the project. And two requirements for this text that our tool produces is that it has to be correct. While if you generate text by a language model, you don't always know if it's going to be correct or not. So we needed to have guarantees that the content is correct, and also that the process is explainable. So if the system tells about some result, the user of this system has to have the ability to go back and ask the system, why did you produce this text? Where does it come from? If the user is a historian, a researcher, they want to know what's behind the observation. So it's not enough that they get the text, the report, they also need to know how it came about. So here's an example from an analysis we did. Tallinn was discussed during 17 distinct years between 1889 and 1918. The mean sentiments towards Tallinn were so and so. This is not the most fluent and colorful text. It's plain facts, but we know it's correct by construction, and the system that we built allows the user to ask for any individual fact. Where did this come from? Why did you tell this to me? So I'll stop here, and without any break, I'll ask Antoine to continue with his part, and then we will have time for questions and discussion.